Let's try to solve this problem. This is of Cauchy's linear differential equation, and let us write in the normal form now. As we have seen in the previous videos, let us write down the same thing format which we have done. So this will be x square d square into y plus 2 times xd into y minus 12 into y is equal to x square. You have this as x square and log x. So this I can again write as x square d square, right, plus 2xd minus 12 into y is equal to x square into log y, right? So further, let us substitute log x as z, right, and x as e to the power of z, right? Now further, what we are supposed to do is, let us substitute xd as d1 and x square d square as d1 into d1 minus 1, right? Now let us substitute whatever I mentioned here. So this is d1 into d1 minus 1, right, for x square d square, and this is 2 times d1, right, for xd minus 12 now multiplied by y, so which is equal to x square log x. So even that can also be replaced as, let us replace that as e to the power of z whole square, right, into z, right? Now on further simplification of this, so I get this as d1 square, right, plus d1 minus 12 into y, which is equal to z times that of e to the power of 2z, right? Further, now what we have arrived this as this whole thing as a normal differential equation. Now we can further continue to solve this. So let us solve this. The auxiliary equation corresponding to that, so the auxiliary equation corresponding to that would be m square plus m minus 12 is equal to 0. So we get the roots as m as 3 comma minus 4, right? Now the complementary function, which is yc, is c1 e to the power of minus 4z right, plus c2. Now this is e to the power of 3z, right? So now let us write in terms of x. So this is c1 x to the power of -4, right, plus c2 and x to the power of 3, so that is x cube. Now let us find the particular integral pi, which is yp is equal to this is z into e to the power of 2z divided by, now we have simplified that, so this is d1 square plus d1 minus 12, right? Close the brackets. Now on further simplification, let us now let us replace d1 as d1 plus 2, right? Let us substitute that, and we are keeping e to the power of 2z outside, so this you get 1 divided by whole thing, so this is d1 plus 2 whole square, okay, plus d1 plus 2, okay, minus 12, right, and multiplied, don't forget z. Now try to simplify the denominator, so what we get here as e to the power of 2z outside, so when I try to simplify this completely, so I get 1, this divides by d1 square plus 5 d1 minus 6, right? So close the brackets, so multiplied z. Now I can take 1 by 6 outside, and further I can simplify it, and minus 1 by 6, which I said I can keep it outside, so e to the power of 2z, this is multiplied. Now I can write this as 1 minus of d1 square plus 5 d1, right? So this divides by 6, right, and its inverse, so multiplied into z. So let us try to expand this, so 1 by 6, and this is e to the power of 2z, right, and when we expand this, I get 1 plus, this is 1 by 6 times that of d1 square plus 5 d1, right, 5 d1, okay, close the brackets. I don't require other terms, because when you multiply that with z, so that goes to 0. So let us write this e to the power of 2z, right? So this is 1, and if I multiply it, so I get this is z plus 1 by 6, and the first term goes to 0, because 2 time differentiation it becomes 0, so this is 5, 1 time it is 1, right? So close the brackets. So further let me complete this. So after simplifying, I get I can take 36 outside, 6 outside, so this becomes 36. And if I put this as 6z plus 5, right, into e to the power of 2z, right? Okay, further after that, so your yp would be minus x square divided by 36 and multiplied by 6 log x plus 5. So this is your yp. Yc we have already calculated that. This is your yc. Let us put that and you get the total solution, that is y is equal to yc plus yp. Okay, let us see next problem. Now if you look at this, again the same process. So let us find the solution for this. So this can be written as x square this is x square d square into y, okay, minus xd into y plus this is 2y is equal to x sine log x, right? Fine. And now let us write this: x square d square xd plus 2 into y, okay, is equal to x sine log x, right? Now let us put log x as z, right? So you will have x is equal to e to the power of z, okay. Also xd as d1 and x square d square as d1 into d1 minus 1. Okay, let us see that. So this is d1 into d1 minus 1, right, minus d1 plus 2 into y, okay. So x is e to the power of z and this is sine log x is z. So you got this. Now further simplification, let us do that. So after simplifying this completely, so I arrive into d1 square minus 2d1, right, plus 2 into y is equal to e to the power of z and sine z, right? Okay, now this is ordinary differential equation and it is second order differential equation and non-homogeneous. Now let us find what is auxiliary equation corresponding to this: m square minus 2m plus 2 is equal to 0. So you get, since it is a quadratic equation, you get two roots, so m is equal to 1 plus or minus I. So you got this as root. So the complementary function, which is yc, is equal to this is e to the power of z, right? This is multiplied by c1 cos z, right, in terms of z, okay, and c2 sine z, right? So let us close the brackets. Okay, we have got this. Now let us write in terms of x on the right hand side. So yc is equal to, now e to the power of z is x, and this is c1 cos of log x, right? Because we have taken z as log x. So plus c2, this is sine of log x, right? Close the brackets. So you got yc. Let us find what is yp here. So yp will be, now this is e to the power of z, now this is sine z divided by now this is d1 square minus 2d1 plus 2, right? Now let us replace d1 as d1 plus 1, right? Let us substitute that. Let us see that. So yp is, you take e to the power of z outside, okay, because you are replacing d1 as d plus 1. So let us substitute that. So I'll get d1 plus 1, and this is whole square, okay, minus 2 d1 plus 1, right? Close that, plus 2. So multiplied with sine z, close the brackets. Let us further simplify it, e to the power of z, and this is 1 divided by, if I try to simplify this in the denominator, I get d1 square plus 1, right? Close this. So I get sine z in the numerator. Let us simplify this. Now when you put d1 square as minus 1 square, okay, so the denominator goes to 0. So what you are supposed to do, your function f of d is d1 square plus 1. So f dash of d is 2d1, right? Let us do that. So you get yp is equal to, now when you are doing that, you have to multiply with z. So e to the power of z into z. So this I'll have 1 by 2 d1, and this is sine z. Now we have 1 by d1 as integration of that function, which is dx. Let us do that. Now your yp will be, this is z e to the power of z divided by 2 and integration of sine z and dz. So integration of that is minus cos z. So let us put this z e to the power of z divided by 2, and this is cos z. So this would be minus log of x divided by 2. This is multiplied into x. So this is cos of log x, right? So this is your yp, right? What you got is yp. So y is equal to yc plus yp. So this is the solution of the differential equation. Right now you are looking into the screen where you can watch out for more videos and also subscribe. Thank you for listening.